Hi, everyone. This is our eighth session where Sally and I are going to continue to explore building standardized enterprise industrial software. Following the best practices, test-driven development, being able to go out there and build, software with confidence that can report any issues, any telemetry issues, or any other details that may threaten the agnostic nature of our software and the resiliency and configurability and maintainability of our software. I promise you, this is not just some engineering jargon. I'm actually, every single thing that I just, said in this just first statement is something that we are going to actually materialize, something that we're going to turn into a reality through our practices here and through these sessions. So I'm just going to go ahead here, Sally, and increase the size on my screen before I share my screen. And then, I need to explain to you a couple of more concepts before we actually start writing code. We're going to jump into code real quick, but a couple of more concepts. In order for us to build software, there is this concept in the software engineering industry that's called test-driven development. Test-driven development. Test-driven development, by definition, means that you don't go directly and just go and say, oh, if I want to add a book, let me call in my storage broker and just say add insert book like this. This would be feature complete, meaning that someone here went and said, I want to be able to add a book, so I'm going to pass a book in here and I'm going to call my dependency, and then I'm going to insert a book, and that's it. This would make the feature complete, meaning that if I want to use this service, if I call add a book, I know for a fact that it will communicate with the dependency, right? And it's going to basically go and add a book into the memory database, which we will eventually evolve. But this practice is really bad. Okay, why is this practice bad? Because if you submit this code, the code gets too many and too complicated. Like you saw in this project OSSS, you'll see the code gets many files and many lines of code, sometimes in the thousands. I built a project that had 1 million lines of code. There's projects, when you're building something serious, you're gonna find out that some of the most popular projects out there has tens and hundreds, almost billions, of lines of code that can go into the system. So if you look at a simple project just like OSSS, if you look just at the foundation, look how many folders, and every folder has 4 files in it, and every file has more information in it, and all that, and so on and so forth. Look how many files in it. So all that code, there is there is something really important that I want you to understand about test-driven development that, basically makes engineers more confident into what they're building. Okay. So what is test-driven development? If you want to write some code, a feature, you have to first write the test that would require that would test that this feature would pass. So before you write the feature, this is the feature here, you want to write a test first. And when you write the test will fail. So you're going to have to go write the feature, and when you write the feature, then the test will pass. Why do engineers do that? Why do software engineers bother writing more code? Because that basically means you have to write more code, right? Because you have not just to write the feature code, you have to write the test code. And more often than ever, the test code is much larger than the feature code. If your test code starts getting smaller than your feature code, just a rule of thumb here, if your test code starts get smaller than your feature code, that means you probably have a function that does too much work. Your function is basically doing a lot of work. This is a golden rule. Again, better listen up. You won't get this in college, right? So there's that stuff. But why do we need to test drive this? Number one thing, protection. You're protecting your feature, right? Protect feature against change. What does that mean? Nobody could just go change the code in your feature, because if they do, this test will immediately fail. Because the test will go and say, wait a second, this feature was supposed to work this way. Someone has changed the code, therefore this test is not satisfied anymore. And if the test is not satisfied, the project doesn't make it through the pipelines, through build pipelines, and doesn't make it through deployment. So you can't go and deploy into production an application that has tests failing in it. Some engineers like to cut corners, but these are, this is just circumstantial, and I hope that they're feeling bad about it, when they do that. But ideally in your pipelines, unless the tests pass, the feature won't be complete. This test has to go green like this. All right. So number one, most important thing, protect your feature against change. Cool. We have this one here. What's the second thing that we care about when we're writing unit tests? Your unit test will tell you alert against incomplete features. What does that mean? You might sometimes more often, this happens with me more often than ever. I would write an implementation that I already wrote the test, and then I go write an implementation, and all of a sudden the test is failing. And I'm like, oh no, I forgot this piece. So it's like you're writing, it's like you're basically communicating with yourself in the future, telling yourself when you write a unit test, hey, you have to make sure that the ID is this and the text box is this and all these little details are in place. Otherwise, we won't be able to complete that feature. So it's alerting you against incomplete features. And this is something that happens to me all the time, all the time. The third aspect here, there's so many good aspects out of, test-driven development, but in here it says plays the role of documentation. What does that mean? In order for you to understand how a function really works, sometimes engineers get too lazy to document their software, right? And sometimes when they want to document their software, they're writing code that, writing comments that doesn't really make any sense. But if you read the unit test, it will tell you exactly why it's behaving the way it's behaving. For instance, a unit test could have three different tests that test three different cases. And from that, you realize, oh, there's three different ways my function is supposed to be consumed. My function is supposed to be consumed. I didn't know that by just reading the code, but now that I'm looking at the test, now I realize, oh, it's a documentation for my code. It's actually telling me, why we built the function this way. Does that make sense?
Yeah.
Okay. What's the cycle of test-driven development? Normally, engineers go like this. First, they write a failing test. So first they make the assumption. What do I want to happen? And then they make that test pass. So they go from red to green. And after they make that test pass, they go into refactor, meaning, okay, now that I know that this function is working and it's doing the right thing, let's go refactor it and make it look pretty. After refactoring, let's go and add more features. So let's write another failing test and then make it pass, and then let's refactor, and so on and so forth. These are the three pillars of test-driven development. You write a failing test, make it pass, refactor, start over, write a failing test, pass, refactor, until you are feature complete. Any questions about this piece?
I got.
All right. Now let's write tests. Let's see what these tests look like. What does test-driven development look like? And for you, because you're just starting this, I'm really excited that you're approaching software engineering, as test-driven development as first-class citizen in your learning. So you're not just learning it after the fact, you're learning it as the fact, okay? So let's go back here and revert all of this nonsense. So as you can see here, when you're developing a function, this function is not ready yet, you throw an exception. You're basically saying, sorry, this function is not ready yet. So if I go in here and go call this function, if I go here and say, okay, I want a storage broker, so here's a storage broker, new storage broker, like this. I swear to God, this Visual Studio is probably listening to me, because while I was writing, it went and said mock. It's like it's hearing me talking, and then it said, "Oh, did you mean mock? Because you were look mock I storage broker." I feel like it's listening to me because it heard me say, "Let's write unit test," and now it's starting to write unit test code for me. And I'll explain mock to you in a second. This is just a funny thing I just noticed. Okay, so let's just go back here and say new storage broker. So that's my storage broker. And then I want to create the book service. So here's my new book service, and my book service needs here's book service like this. And this book service needs a storage broker as input parameter. Remember how we talked about dependencies and this book service wouldn't work unless something satisfies the contract. Remember all that stuff?
Yeah.
Okay, so there's that part here. And then if I go and say book service dot add book, and I'm just adding some book in there like this, doesn't matter, any book, doesn't matter. So I'm creating a new book in here on the fly. Normally I would just go up here and say, okay, create a variable for this and, put an argument or whatever, like something to the effect of var book equal new book like this, and I'm passing this book to my service. What's going to happen here? If I run my application right now, let's go run our application right now. Let's go here and say .NET run project. Here is my Sally library. Here is my was that a folder name? Oh, okay, fine. Okay, so Sally library app project. Let's run this guy. This guy's supposed to blow up. Here you go. What is it saying? System not implemented exception. The method or operation is not implemented, meaning that the code that is supposed to be there is not there yet. And that's what an exception means. Okay. Stop me at any point in time. This is a little bit, some of that stuff is very advanced, but we'll come to that part in a second. Okay. How do we test drive? How do we write a test first and then write the function that implements that test? Here's what we're going to do. I'm going to go up in here and create a new project. And this new project is going to be called, I'm going to use X unit test. I don't know if it's visible through what I'm sharing. Is it visible? Do you know?
A part of it on the left side. No, it's okay.
Now it's good? Okay, perfect. And I'm going to name this project what? I'm going to say Sally library .app.tests.unit. So I'm writing unit test, naming convention. Teams do it differently. Here is what you have on my side. Okay, so I remember how I said services, foundation, books, and I broke down the services into different things. I'm going to do the same thing in here. I'm going to create a folder that's called services. Services. And under services, I'm going to create foundations. Under foundations, I'm going to write the test, that the class that basically explains the test that I'm writing. In this case here, it's book service tests.cs. Okay, so now I basically went and I wrote a, let me put our copyrights in here. Here you go. Here you go. So I'm basically wrote a function. I know why I don't know why this new template is making our classes internal. Weird template, but it's a latest and greatest Visual Studio. So there's still some work there. It's still on the bleeding edge. Okay. So I want to test my function. I want to go and say this book service in here. I don't care that it's calling the actual database. So I want to fake a dependency that is being passed in here to see if this function is doing what it's supposed to or not. It's like sending in a spy. This is a spy. I'm going to send a spy that looks like a storage broker, but it's not really a real storage broker. And that spy is going to tell me whether my service here is calling the right stuff or not. Let's see how that works. We're going to use a little library here called mock. Mock basically is faking an implementation of a particular library, of a particular interface. So if your contract is called iStorage Broker, it will say, okay, I'm going to go fake an iStorage Broker, something that implements that contract. But it's not really implementing that contract. It's just a spy. It's just listening to what's happening in your service. And I'm going to instantiate also the service itself that I'm working with, which is iBookService. So that's book service. There you go. So these are all the requirements. These are all the ingredients that I need to go and start the ingredients to test a particular service. Let's open up the constructor in here and let's instantiate the storage broker with a mock, and let's instantiate the book service with a new book service. And what am I going to pass as a parameter for this new book service, Sally? What should I pass in here as a parameter?
Oh, the fake one.
The fake storage broker, right? That's exactly right. So I'm gonna go here and say for this storage broker, this dot storage broker mock dot object. There you go. All right. So now I instantiated this service here with a fake mocked up dependency. A fake mocked up dependency.
Okay.
This service thinks that it has the right dependency in here, but it's just a listener. It's a spy. It's telling me what's going on with the service when I call something in that service. Let me show you an example. If I go up in here and say, here's an example. Let's write a test. Here's fact, like this, fact. And I'm going to go up in here and say public void should add book. So that's my test. My expectation is that this test should add a book into the database, right? I'm not testing the database, but I'm faking it, faking this database here.
Mm.
So we're going to break our test into three things. There's given, when, and then. Given is where we define our variables, our ingredients that we're going to use in this test. For instance, I can go up in here and say book or random book equal new book. I'm creating a random book in here. Just a random book, in here.
Mhm.
And then I'm going to go and say this book is my input book. So this random book, I want it to be my input book. And then I'm going to go here and say something to the effect of storage book. So this is the book that I inserted. They're all the same reference, right? And then one more thing in here that where I go and say expected book. So what did I do here? This book that I'm trying to test, first of all, I created a random one. And then I went and said, what I'm going to pass in is going to be created out of this random book. And what's coming from storage should be the same as the one that I inputted in. And what I expect to come back from the service should be the same as what the storage returned to me.
Can you repeat that again?
Yeah.
So,
So these are all variables that have the exact same value, all of them. I
Mhm.
only change their names based on where I'm going to use them so they make sense in terms of the context of the code that I'm writing.
Mhm.
Here's an example. If I go like this and say, set up this spy, this storage broker, it's a spy, right? Let's set up this spy that when it is called with this input book, that it will go and return the storage book. See how I'm making this spy operate the way I want it to operate. I'm describing its behavior because it's not really going to go and call the real database.
Mhm.
It's going to pretend that it's calling a database. Okay, so look, these two are the same value, but when I am inserting, it's best fitting from a readability standpoint to go and say input book when I'm passing an input and to say storage book when I'm returning what I have passed into the database. They're all the same variable. I'm just giving them different names. So I defined a bunch of variables and I used already two of them in here. In this area here, I'm going to define a book that I'm going to call actual book. And that's actually the service, the real service that I'm calling with the fake dependency. And I'm going to pass to it the input book again. So I'm basically telling my service, hey, take that input book and persist it in the database. The service doesn't know that I passed in there as a dependency, a spy that's listening to what the service is doing underneath, right? But I'm going to go out there and verify and say, well, service, you're supposed to return whatever that you persist in storage as an actual book because this function returns a variable. So I'm going
Mhm.
to go up in here and say actual book should, this is another library that I need to use. It's called Fluent Assertion. Give me a second here. Let me get Fluent Assertion real quick. Fluent Assertion, there you go. Here it is. There you go. So this actual book should be equivalent to expected book. What I'm basically saying here, this then area is where you are verifying that everything this function have done is correct. So I passed in an input book in here, and I'm basically saying whatever this function has returned as an actual value should be a match to what I built as an expected. Why should the actual match the expected in here? Because the storage broker is returning a storage broker, a storage book that is the same value as the expected, right? So if this guy passes something in there, it should return the same thing that I passed in. Okay, that's one piece. I also want to test something else. I want to go here and say, this storage broker, this spy, now it's time to talk to that spy and see what happened after we've made the call, right? So now this spy is telling me, I'm asking the spy, say, hey, have you been called with this new book that I passed in? And how many times have you been called? You're supposed to be called only one time. So I'm basically telling my spy, hey, I already set you up that when this particular book is passed into you, you're gonna return this. Now I'm verifying that this function has actually called this guy, because anyone could go and say, okay, I'm not gonna call storage. I'm just gonna return the same thing that I passed in just right away. So this here ensures that this function here has actually called the database. And then the last thing I do here, which is a little bit of an advanced topic, is to go and say my storage broker mock verify that this function have made no other calls to the database except for the one that I specified in here. That's it. That's our test.
Why you did that, the last one?
This last one, so the function doesn't go and call other functions like this function here. So it doesn't go and use this dependency, this storage broker here, to call other functions underneath without me knowing.
I see.
So this basically restricts this function from doing any other calls except for the one that I specified.
And this is
Let's
inside
go ahead.
basically we're doing that.
This is what? Repeat that.
Within the test, basically.
Yes, it's all within the test.
Okay.
This whole function here is just the test. See how big the test is? Because in the test, you're actually telling the whole story. In the test, you're going and saying, okay, I'm going to create a random book from nothing. And then I'm going to define an input and a storage and an expected. And I'm going to pass the input in here and in here. And I'm going to pass the storage as a return type. And I'm going to create an expected that I'm going to compare to the actual. So if I were to write this as a human language, I would go and say this. Define random book. And then define input, storage, and expected book. And then go in here and set up your fake storage storage dependency to take here dependency to take in the input book and return the storage book. And then underneath, run the program against your subject of test function. Save the result when you run the actual function in actual book variable. Okay, and then compare actual book with expected book to make sure you have the same value. And then verify that your dependency has been called at least, has been called exactly one time with the exact same input variable input book. The last thing, verify that your dependency is not being called again. Let's break this. So this is here given, and this here we're testing the actual function. So I'm going here and says when. What the heck? Hold on. When. And then down here I'm basically going and saying then. It's really, really important that you understand this one. And it's a lot to throw at you at once, but just take it easy. So in here, I'm basically saying define bunch of variables and then set up a fake storage dependency to take in the input book and return the storage book. So we're faking it, like we're faking a call to a dependency that is not really being called. And then let's go and run our real program and save the result that's coming out of this real program. So later we can compare the actual book that came back versus the expected book. And then in addition to that, let's verify that our dependency, this spy, let's go ask this spy, how many times have you been called? And have you been called with the right variables? And then the last thing we also say to the spy, make sure that there is no other calls that have happened to this function. Now it's time for your questions. Any questions at all around this part?
Just generally, what you define as dependency, like in that concept, like we had book services and iStorage. iStorage count as a dependency to the
Yes.
book services.
Yes.
What is the general definition of dependency?
Yeah, this is really what a dependency is. Something the service needs in its constructor when it's being built, and it calls in order for it to perform its function. So a dependency here, this is why we say dependency injection. So what's a dependency? Dependency, right? Something a service calls in order to be able to perform a certain function. So the service calls this dependency to be able to perform a function. For instance, what we're trying to do here is that in order for this book service to complete its task, it has to call that storage broker to actually persist the data in the database, right? So that's something the function has to call in order for it to fulfill its purpose. In order for this function to be able to fulfill its purpose. What do you think?
This is clear. And then I'm trying to understand the last part when we say it does not verify other calls. Verify not other call, basically. So this is still, I'm confused about that part. That
Oh,
okay,
this last one here?
that's one. Yeah, the concept of that.
Oh,
Um,
this
in
concept here.
what
Go ahead. Go
I
ahead.
want to know in what, like, if you can tell me example that is been called many times. So, for example, can
Okay. Yeah. For example, here's an example. For example, let's say your function here went in and said, instead of calling just the storage broker and do insert book, it also went and called the storage broker to do an update.
I see. Okay.
Or even worse, if it goes and does this like 3, 4, 5 times, right?
Mm-hmm.
This will catch that. This will make sure that this unwanted, undocumented, untested behavior doesn't go through, doesn't happen. See what I'm saying?
Mm-hmm. Mm-hmm. No.
That's it. That's all that it is. You're just going and saying, let's make sure that whatever whatever is whatever is happening in this function is being monitored. Does that make sense?
Mm-hmm.
Okay, go ahead. What else do you have? Anything at all? This is your time to understand unit testing.
Problem. So what would be so if it is like you put in zero, so what is, so basically it called many times. So monitor that is called many times. So what would be the consequence? Can you explain that again? So you mentioned that
Mhm.
is something that is caused the problem for the test, right?
Yes. So what's the consequence? Why do we care this would cause a problem for the test? Because the test responsibility is to ensure that the feature that you're building is running exactly the way you documented it to be, not based on any other rogue code that may end up in your function. your test tells you, be careful, your code, your feature has changed and it doesn't satisfy the feature that you're shooting for originally. Does that make sense?
Mhm.
Hmm. Let's try it. Let's see what happens. I'll show you all the different cases. Okay. So let's take away all that junk. Let's throw that away. You know this off the top of your head, right? Okay. So let's
Is it?
see. So if I run this function now, do you think it will pass or will it fail?
It should pass. Oh no, we didn't define. Hold on, in the other.
Hmm.
No, it should pass. Right?
Do you think it will pass? Okay.
Um, I think it does.
So you think it will pass, right?
Yes.
Yes. No. So let's run it. Let's see why it will pass. Let's find out. Sorry. Let me fix this. Let's see why it would pass. I'm gonna go up in here. I'm gonna click run and let's see. So here I'm running the function. You can see your unit test here in the test explorer. See, it failed. Why did it fail? Because the function that we're calling here didn't satisfy any of the conditions that we set in here, right?
Why?
The, the test failed because if you go into this add book function, it didn't call the storage broker. It didn't do anything. It's empty. It's not doing anything.
Oh, okay. I forgot about this part. Okay. Mhm.
Oh,
Well,
I see it. I see the confusion because I wrote the code before, but then I deleted
yeah.
it. I understand. So right now this is failing because it satisfies nothing of the stuff that we said it's supposed to do.
Mhm.
Okay. Well then, let's make it pass. When you are writing a function like this, it's always a nice code hygiene to go and say, let me make a special commit that says, hey, I have a failing function in here. So making a
Mhm.
commit, we're saving the code that says I have a failing function. Why is that? Why is that important? If your function failed or your test is bad, you can revert back and it also keeps track of the contributions of the team on the code. It basically keeps track of all the steps that you're taking. A lot of people make the mistake of writing a lot of code and then putting it in one single commit. And when they need to go back and revert one tiny change, they can't because the code is so many, and now they have to go and create another commit on top of it. So it's always a good
Mhm.
hygiene. I call it a purist approach. Purist approach meaning you're purist. You're basically saying every step is documented, every step is saved. Especially when you're pairing, like you and I will be pair programming. I will be writing a failing test. I'm gonna give it to you, and then you're gonna make it pass, and then you write a failing test, and then I make it pass, and so on and so forth. So, okay, how would we make this function, how would we make this test pass, Sally? Let's go here and let's just do what the function is asking us to do. The function here is telling us, hey, whatever you return should match what you passed in from the storage. And I need you to call this storage broker at least once.
Mhm.
Let's go verify that. So let's go back here and say, well, here's a book. Here's storage book like this. And I'm going to go and say this dot storage broker insert book. So this is the first step. The first step here is that the storage broker, the call that I made in here have succeeded, right? The second thing is to just return that storage broker, to go and say, here's your storage broker. Sorry, storage book. Storage book like this. Once you return the storage book, this is done. So we satisfied the two conditions, the two requirements that this function is asking us to do. The first requirement is that it should return a book. The second requirement is that it should call the dependency. Does that make sense?
Yep.
The third requirement is that it shouldn't do anything else other than these two things. So what do you
Mhm.
think now? If we run this now, do you think this is going to pass?
Yes.
Okay. I don't know. Let's find out. It passed. It went green,
Mhm.
right? So that basically means that whatever whatever you want your function to do in here, whatever you want your function to do in here has satisfied. So if anyone goes into your test, sorry, your implementation here, if anyone goes into this implementation here and does something funny, let's say someone went in there and said, no, it's not insert, let's do update like this, and they try to run your test, what's going to happen to the test? It's going to explode. It's going to fail. Why the
Mm,
test is failing? It's going to go and tell you in here, hey, you told me you're going to call the storage broker, but you didn't.
mm,
You didn't call the storage broker. Look here, expected actual book to be equivalent to this, but you got nothing back
mm,
because this guy's returned nothing, null. It didn't do anything.
mm,
So you see now how our unit tests is protecting your code from being modified.
mm,
When you build some million lines of code enterprise application, these unit tests are your protectors from any changes that you're not aware of that may break your system.
yes,
Because any change that will happen to that system, it will break the unit tests for it.
mm,
That's a lot of stuff to throw at one person in less than 45 minutes. So let's try to kind of let me first make this test pass in here. So this test is passing here. Pass like this. And then I'm gonna add one tiny thing on top of this before I ask you the question and all that. There's a problem here. I have run this style of coding with some of the people that I work with, and someone told me, Hassan, your test is flawed. And I said to him, why my test is flawed? She said that if you go and do this, change, your test is not gonna fail. Look, if I run my test like this, it's not gonna fail. And that's a big problem because that means there is code here that has changed and my test couldn't detect it. And that's a huge problem. So how did we fix this problem? We went up in here and we added a tiny library that basically takes a copy of the code that is being passed in. So something called deep cloner. So it basically takes a copy of the function of the object that I'm passing in. Let me take a copy here. And I basically went and said, okay, instead of passing all these parameters and them having the exact same reference, let's deep clone. Let's take a copy of the expected. So when we compare things, we know that this is the most pure form of these parameters before we passed it in. Now, if I run my test, this is going to blow up. Watch this. Boom, blowing up. This standard change was introduced by a software engineer. Her name is Shri. She's very, very smart. And she basically went in and said, Hassan, I think our test is flawed. Our test is
mm,
broken, right? Um, it's very interesting. So now if I go back here and take this change out of my test and run this again, this should pass. So now we actually are feature complete because that basically means nothing that can come in or go out of that test that is not accounted for unless it would fail. If I go on the top here and say book.title, I'm gonna pass in this title and go like this and change something, watch what happens. Watch this. Fail. Because you did something that you're not supposed to do in that test.
mm,
All right. Now here's the deal. Here's the deal. It's your turn. And your turn here would be, let me just clean this up and go and say, okay, this is a deep clone. This is here. I'm gonna go and say code rub at deep clone. It's amazing when you work with a bunch of engineers, you know, and you pour your heart out. You actually want them to be better than you. They will help you show you things that was for the longest of time, years and years, I've never knew about this deep clone thing. Like I didn't even think of it, that the references are changing. Like these are all the same references until someone comes along. If you put your heart out and you teach people really, really well, it will reciprocate. Gratitude reciprocates. And this is what I saw in here. Okay. Do you think you can write me a failing test? A failing test that tells me that I'm supposed to have an update or modify book function on my
Mhm.
system. So can you pull that code from GitHub? Do you have it pulled down on your machine yet?
No.
Okay, so let's make this an assignment for you because we're almost at time. Here's what I want you to do. I
Okay.
want you to pull that code down and clone it, and then
Mhm.
write me a failing test. Write me a failing test. That means you're going to have to define a function in here called modify book.
Yeah.
Write a failing test that tells me that this function is supposed to call modify or update on the storage broker, and then I will make it pass. What do you think about that idea? Do you think you can
So
do that?
I will try.
Give it a shot. Do you have any
Yes.
questions about all of this? This is a
I
lot of stuff today. Go ahead.
I
Go
just
ahead.
saw you create a deep clone. I missed that part. So.
Oh, this deep clone, I just added a library in here called deep cloner, and I just called
Mhm.
it called dot deep clone, and it just showed up.
And can you show me how you add libraries? So, like,
Oh
I
yeah.
mean.
Oh yeah. You go right click like this, and then you go manage NuGet packages.
Mhm.
And then you go find the NuGet packages. NuGet packages are basically it's a bunch of libraries, .NET libraries of really, really nice, smart people out there that put libraries so they can save you the work that you would do manually. So you don't have to do that work manually,
Mhm. Okay. I got.
right? But you
Should be.
won't have to add it again in your assignment because I already added it. But what you're really
Mm.
gonna need to do, you're gonna need to write a function here that says should modify book.
And
And I'm
what
gonna
is
link.
this? Sorry, what is this fact? I didn't got that you
This
put fact.
fact here, yeah, this
Mhm.
fact here is what tells the system, the IDE, and what tells the framework that this is a test or just a normal function. So there are so many functions out there, right? When you say fact like this is an annotation. We call it an annotation, and this annotation tells the unit test framework, hey, this is a test function. Go ahead and run it and show the result on the back here, right?
Mhm.
Like I could go in here, like I can go in here and say public void should be true. Just a dumb test, just any test, right? True should be true, right? Just a really dummy test that doesn't make any sense, right?
Mhm.
If I run my test right now, all my tests in here, this function won't run. You won't see should be true in here. Why is that? Because I didn't annotate
Mhm.
my unit test function with this fact stuff. And we're going to learn about fact and theory, of course. But here's one in here. If I put fact in here, now watch this. If I run, see, now it showed up. The framework knows that there's a new unit test in town and
Mhm.
it needs to be taken care of. So that's what this fact means. There's two things. There's something called fact and something called theory. Let's just focus on the facts now, and then we could talk about the theories later.
Sounds perfect. So yeah, I'm happy to go for my assignment now. See you
Okay.
test my learn
Okay.
this or not.
All right. Read about unit test driven development, unit tests.
Where
Take a look at
where
in
should I?
OSSS. Look at the code. Look at the test code in OSSS.
Mhm.
OSSS now is your reference. Go there and read about it. And also you can also take a look at it in this area here as well. If you go to the standard, you'll see in the foundation services, when I
Mhm.
start introducing, see, should add student.
Mhm.
Input, storage, expected, deep clone. And I even made a section here about the stuff that Shri and Naveen talked about. I went in here and I said, um, you will also notice that we deep cloned the expected student variable to ensure no modifications have happened to the originally passed in student. So that's their contributions. When I see this text, I see them. I see Shri, I see Naveen, I see these people that helped me build build software. There's so many. There's Shimmy, and maybe one day you'll be able to go and tell me, Hassan, your standard is dumb. There's things that you can do that can make your standard a lot smarter and a lot better. We continue this evolution, continuous, hive mind evolution of building a world-class global universal engineering standard. And this is what I have so far.
Thank you. Wow.
Okay,
Now I
cool. All
okay,
right.
thank you.
I,
There, I
I'm
didn't know.
excited. I'm excited for you because, starting in this industry, I didn't find a standard. Nobody told me do this. I had to go find all that stuff on my own, and it took a very long time, Sally. Like when you and I sit down and talk about this, I'm trying to skip on your behalf years and years of trials and errors, and that's the whole point of mentoring, and that's the whole point of teaching people. You learn from these people, but you're teaching people, but they also learn from them. And sometimes you learn, like just like I told you yesterday before we started recording, you help me revisit all the concepts that we have today so I can verify and validate against how you perceive these rules and how you perceive these standards, whether I'm going on the right track or am I too high on my in my ivory tower. Again, thank you so much for coming in today. Thank you for your due diligence. You have an assignment, you have a repository that you need to clone, and just make sure things are running on your machine, and we'll connect again next
Thank,
week. Sounds good?
thank,
Thank
perfect.
you, Sally. Have
You.
a good night. Take care. Thank you. Bye.